Hello, in this video I want to show you some new features that are now available in AIDeveloper 0.1.1. Please note that the link to the releases is now on the right side of the GitHub repository page, and this link will guide you to this list, and there you will find also downloadable zip files. You just need to download it, unzip, and then you will find there the executable within the folder. The new features that I want to introduce mainly affect the expert menu. You can find the expert menu in the rightmost tab. Typically, this expert mode is switched off by default, and switching it off also resets the values back to default values. The default values will work well in most scenarios, and only if you want the extra little bit of accuracy, you can switch it on and then experiment with the settings in here. You can see here that you can change the optimizer and the learning rate, and this is actually what I want to talk about today. Here, for example, we have the optimizer atom selected by default, and if we change that, let's say, to add a delta, we can see that there's a pop-up telling me that the learning rate was set to the default for eta delta, which is now 1. So now the learning rate is 1, and for Adam, the learning rate is 0.001. So apparently the learning rate for both optimizers is different, but the question is, how do you know which learning rate is best in which setting? And to answer this question, a learning rate screening was suggested in a paper called Cyclical Learning Rates for Training Neural Networks by Leslie Smith. And this has been now implemented similarly into AIDeveloper. But to use this function, you actually are training a neural net, which requires obviously some data. And in today's tutorial, I would like to use data we've published in the AIDeveloper paper called AIDeveloper Deep Learning Image Classification in Life Science and Beyond. And more specifically, there is a data set where we try and distinguish B and T lymphocytes based on their bright field image. In this document, you will also find a link to the data, which is this link here. And on figshare, you can then download these folders. And here you have the folders and files for the B versus T lymphocyte discrimination. I already downloaded those, as you can see here. And in the folder for the model, we can not only find the final model, but also the history for that model. That history can be loaded into AIDeveloper by using file load session. So since the folder structure changed, I have to let AIDeveloper know where the data is approximately located. So now it will search this folder and assemble this table for me. The dataset, the training and validation dataset, was assembled in the same way in this publication. Also, in this Excel file, I can find the parameters which have been used during training, such as if horizontal flipping was applied, the rotation, and so on. And I already put those particular values into this form. And now we're good to go to do a learning rate screening. But first we need to define a model. Okay, I want to use the same model as has been used for the paper. Okay, so now I'm good to go, and I can click this button for the learning rate screening. Here we again see our current settings for the model, and I can define the range in which I want to screen the learning rates. And if I'm fine with these settings, I just hit run. If you are on Windows, you can then see in the console that it's loading the data. Now it's preparing the neural net, and now it's training the neural net for 5 epochs as indicated here. So now in this graph, on the x-axis, you can see the learning rate on a log scale. So for very low learning rates, we can essentially see that the loss does not decrease. When training a neural net, we always seek to decrease or to minimize the loss. And you can see at a particular learning rate, we start to decrease the loss. But if we increase the learning rate too much, the loss becomes noisy. Therefore, the optimal learning rate would be something in between. And it happens that 0.001, which is the default learning rate for Adam, is right in the middle. So 0.001 would be a good choice and has actually been chosen for the training of the model that was published in this AIDeveloper paper. And I would like to now load the history of this model. We can see here at the very end of the training that there is still quite some fluctuation in the validation accuracy, which essentially means that the weights of the neural net go back and forth too much, and this means the learning rate was too high. By decreasing the learning rate, one could decrease this scattering and let the neural net converge to a more stable model. This fluctuation also means that the validation accuracy, for example, for this model here, is just really high by coincidence. And this accuracy might not reflect the accuracy you would get on a new data set, such as the testing data set. And also in this paper, you can see that while the validation accuracy was 89.3, the testing accuracy is only 86.2. So I will now try to load the best model that was found in this training and then continue the training process using a lower learning rate and also reduce the learning rate automatically during training. And this can be done, for example, using an exponentially decaying learning rate. But first, let's load the last model. I want to train only for 250 epochs, and I would like to use a continuously decreasing learning rate. And there is a button which allows me to show how the learning rate will behave during my 250 epochs. If I would like to let it decay slower, I could use 300 decay steps. So let's use 200 decay steps, so that looks good to me. And let's try that setting and check whether we can actually get a more stable model. Okay, here you can now actually see that at the end of this training, the scattering of the validation accuracy is much lower than at the beginning, which is because the learning rate decreased, and we can also plot the learning rate. You can see it here, how it exponentially decreased, and besides the exponentially decreasing learning rate, there's one more schedule currently, which is the cyclical learning rate. And here you can also define a range in which the learning rate goes iteratively up and down. Let's say we want to start with 0.0001 as the lower bound and 0.0005 as the higher bound. And again, we can now plot how this would look like. So let's say we want to use these settings after the next epoch, and let's train this for a little bit longer just to see what will happen with the learning rate. So now you can see that the learning rate increases linearly, and now at 0.0005 it starts to decrease again. So these are the boundaries that I defined. Okay, now let's have a look into our history. So I click live to see the most recent history and update plot. Now we can see all the iterations, but I only want to see the models that were actually saved. And the model with the highest accuracy that was also saved is this one, iteration number 69. Now let's load first the testing data. And for that, we can again use the load session option. For testing, there's also a session available, which I downloaded from figshare. This is the dataset that was used for testing also in this paper. Now I go to the Assess Model tab and load the model 69, and I apply it. So here we can see that the accuracy is now 86.5, which is actually a little bit higher than the testing accuracy reported in that paper. Okay, this shows that using a learning rate schedule can allow you to train your model in a way such that the model accuracy converges to a particular level, and that accuracy is then also more translatable to new data. Besides the learning rate, in AIDeveloper 0.1.1, you can now also not only change the optimizer, but also change the momentum or the row parameter of this optimizer, and you can check in the literature what these parameters mean or just experiment with it. Okay, I hope you found this tutorial helpful. Have fun. Goodbye.